Yeah, hello and welcome to our last lecture in our lecture series in winter semester of our lecture series Climate Protection. So today we have a special guest, Anke Bockreis. Anke Bockreis is Professor for Waste Treatment and Resource Management at the Unit of Environmental Engineering at University of Innsbruck since 2009. Her main research activities are in the field of solid waste, wastewater treatment, and anaerobic digestion technologies. She was Vice Rector for Infrastructure of the University of Innsbruck for 8 years, and she is winner of the Sustainability Award, Ögut Umweltpreis, and received the Great Decoration of Honor for Services of the Republic of Austria. Today, she will speak about climate change and what can circular economy achieve. Welcome, Anke Bockreis.
Thank you very much. I hope it works now. I want to tell you something about climate change and circular economy, with special focus on waste treatment and waste management. And it's something you all produce. Nobody wants to live near such a treatment plant, and we have some discussions there. But it's something which we all have to do with it each day, and it's a very interesting topic, and we can have a big effort or a big relevance to the climate change if we can reduce waste and the emissions coming from that part. This is I wanted to show you. So first I want to tell you, probably you know the CO2 emissions in Austria, but I want to show you the focus of the contribution of the waste sector to the CO2 emissions. And then I want to talk to you about the climate protection through more circular economy. And one main first thing is the strengthening of the public awareness of waste prevention, because it's not only, we really have to do a big focus on waste prevention. The best waste is the waste we didn't produce. And therefore we need to have bigger awareness, higher awareness of the public regarding the topics of the waste. I want to show you that we need an increase of the value of the products and the secondary products, and we need more design for recycling, which we don't have in a lot of cases at the moment. And technology plays a role. We need to take into account this cascading approach. We want to talk a little bit about the elimination of pollutants, because if we doing it more circularity in the waste section, one thing is not to use the pollutants in the circle. So we have to think about how to get out the how to eliminate the pollutants there. And last, I want to talk about the promotion of the circular economy through regulatory measures, and sum up with conclusions. Yeah, this scene is probably known to each of you, especially in such kind of lecture. It's the trends in Austrian greenhouse gas emissions from 1990 to 2020, and the target path we are fulfilling more or less a little bit in 2020, also with the help of Corona. Now the emissions is not decreasing, it's increasing again, and we have to do something here. And most of the CO2 emissions regarding the different shares of the individual greenhouse gases, we have the CO2 emissions as the main part, but we do also have the methane emissions coming also from the waste sector, but also from the agricultural sector. We have the N2O, the fluorinated gases, and coming from the cooling, for example, of the houses. And this is one increasing substance in the last years. When we come to the contribution of each sector to the greenhouse gas emissions, you can see here the distribution. We have gotten a high amount of 45% in the area of energy and industry. We do have the traffic with nearly 30%. We have the contribution of the buildings, the heating of the buildings, the operations of the building in the range of 11%, the agricultural side 10%, 11%. And we do have at least 3% coming from the waste management. This is more or less a good number because we have reduced the emissions coming from the waste management very much in the last years. And this has to do with the closing of the landfills. I will tell you afterwards. If you have a look at the change between 2020 and 1990, you can see that we achieved a reduction in waste management in the area or in the sector of waste management, as well as in the area of agriculture and buildings as well, and energy and industry. But we do have an increase in the area of traffic and the fluorinated gases, which is also related to the cooling of the houses, especially when the summer is still getting warmer and warmer. If you have a closer look to the main sectors of the emissions coming from the waste sector, you can recognize that we do have four different treatment methods, which is landfilling, is biological treatment in order to produce compost as a fertilizer, the incineration, and in this section also the wastewater treatment. And you can clearly see that we achieve a big effort in the range of landfills. We do have a reduction from 1990 to 2020 in the area of nearly 80%. And this has to do with a very strict regulation in the landfilling in Austria, because it's forbidden to, since 2005, with a little bit more years to some federal states, but generally it's forbidden since 2005 to bring waste to the landfill without pre-treatment of the waste before. So we really introduced much of the CO2 emissions with the focus on the methane emissions, but we do have an increase in the area of incineration, because incineration is one kind of pre-treatment method before we do landfilling. And so we are incinerating a lot more of waste, and this is a number which is increasing, but starting from a very low number in 1990. So we are now more or less in the same range as the landfill's emissions regarding contributing to the greenhouse gases. And here you can see the picture and the success of the material going on a landfill. You can see one thing, the blue lines or the blue columns is the amount of waste which is disposed of annually, and the yellow line is the methane emissions coming from landfills. And you can see that regarding or in correlation with the closing of the old landfills, how we used to have it since several years, just collecting the waste in the residual dustbins and bring it to the landfills. That is not longer allowed anymore. So now we have a very strict or a very strong decrease of methane emissions coming from the landfill. And this is contributing a lot to the greenhouse gases emissions in Austria, but it's not the case all over the world. We do have the law. It's not only an Austrian law to reduce the emissions from the landfill. It's also a law from the EU. We don't have the same effort in each country. We still have some countries which are still landfilling a lot of their waste, but even the EU members should go into the direction that they reduce the emissions coming from landfills. Worldwide, the view worldwide is very dramatic, because we do have not even something we call the landfill. It's better to say it's a dump site where every kind of waste is disposed of. And regarding to that, there is an initiative from the International Solid Waste Association, founded 4 or 5 years ago, that we have to close the biggest dump sites worldwide, because they are much contributed to the greenhouse gas emissions, and they are also contributing to a lot of death as well. So, for example, within 7 months, the ISPA has recorded more than 750 deaths related to poor waste management in dump sites and several incidents with important health impacts. So dump sites are a global health and environmental emergency, and we have to do it we have to have a good focus on that and trying really to reduce the dump sites and to bring it from dump sites into in the range of sanitary landfilling, which we have in Austria and Germany and a lot of European countries, but worldwide it's a problem. And if we do it like we do in the last years, the scenario is that the dump sites will contribute in the range of 10% of the global anthropogenic greenhouse gas emissions by 2025, which is not very long. It will last 2 years, something like that. So we really have to focus on the big landfills or the big dump sites worldwide. For example, there are several roadmaps for the different regions. And for example, here's the roadmap for the progressive closure of dump sites in Latin America and the Caribbean. And in order to prevent such pictures like this, where all of the material and a lot of packaging material, as you can see on the slide, is thrown in the surroundings. But people also scavengers are living on the landfills, and you can see also the animals are getting their food from the landfills. So we also have to take care about the social dimension of closing all the dump sites, because a lot of people are living from what they're found in there. So we have not only the ecological part, we also have to take care about the social dimension of that. But here, in coming back to Austria and Germany, this is a slide from Germany, we do have a more or less functioning collection system, waste treatment system, and we can see that we can reduce the greenhouse gas emissions through recycling. So, for example, here you can see different materials which were collected separately in Germany: metals, aluminium, copper, plastics, paper, cardboard, and glass as well. And you can see that there is still an enormous saving of CO2 emissions because of the recycling steps. You need less energy if you take old glasses, for example, and produce new glasses out of the secondary raw material in comparison to primary raw material. But you can also see that there is still potential to increase the savings of the CO2 emissions. And we really have to work all together in order to get a better collection, but also have a better recycling rate afterwards and a better treatment as well. So coming back to Austria, we are collecting a lot of packaging material and waste paper separately in 2020, more than 1 million tons. And it's a little bit distributed. It's from the ARA, we are collecting paper separately, packaging, glass and metals, and a lot of the materials were recycled, but not all of them. We had a big discussion what is really a good recycling, or but yeah, we are collecting very much, but we still have room for improvement here in the Austrian situation, because if you think, for example, for a recycling rate of plastic, we are in the range of 30%. I think we could do really a lot more instead of thermal treatment or thermal incineration and just using the energy out of it. And this I want to show you in the next slides, where some examples where how to get off or how to get a better contribution to the climate protection through more circular economy. And these are the topics I showed you in the agenda before. And I wanted to start with with all of you, strengthening the public awareness of waste prevention and treatment, as well as resource efficiency. This is really necessary that we get into the step that we don't produce so much waste as we are doing at the moment. Not only doing the right recycling and treatment afterwards, we really have to prevent it. And we have to bring it into a circular economy, which really means that we should use as less primary materials as possible, but all in the different steps, the waste is produced, and we also have the necessity to get out some materials of the system because of the pollutants of some materials. I will talk later on, but we have to get more linear. We have to get away from the linear system. We have to move into the circular system, and this has also to do with the design process of the product. If if a mobile phone can't be used, or nothing can be replaced, some parts of it you will throw it away because it can't be used anymore, and we have to get into more recyclable production, for example, recyclable design of some processes as well. What we do have in Europe and as well in Austria is that we do have the European waste hierarchy, and this is the first step. Is, as I said before, we really do need the prevention of waste. So we have to take really a lot of effort and not to think, okay, how to make packaging a good recyclable. The best packaging is really the one we don't need. And in our thinking, it's getting as it's too easy, for example, to use it and not to think about it. But we really have, especially in the area of plastic packaging, we really have to think, where is it really necessary, or where can we bring our own cups? Where can we get away from the single-use plastics? And there are other examples as well. If it's not possible to prevent, we are more in this part, and until now the waste management was focusing more on the reuse, recycling, and the recovery. But it's only the 2 and 3, 4 steps of the hierarchy is really the reuse of something. So the first step, preparation for reuse, giving the product a second life before they become waste, the recycling, any recovery operation by which waste materials are reprocessed into new products, and the recovery of energy if it's not working in the way of recycling before. The last step should be, and we will not get out of the last step as well, there will be a disposal, there will be incineration, and there will be landfilling in the future as well, because we will always get some residual which we are not able to incinerate anymore, which we are not able to use anymore, and we will need landfills in the future probably. But the question is how big they should be in the future, or how many we need. We do, even if you are talking in Austria since several years about waste reduction and waste prevention, we do have an increase in the last 5 years, in the last 10 years. As you can hear on the slides, we do have an amount of the total waste in 2014 in the area of 56 million tons, and in 2019 we do have more than 70 million tons. So really we do have a big increase, and you can see the first line is increasing in the highest way. What do you think is it? What kind of waste is it? Plastic. Mm-hmm. What is the first? Also, you can see an enormous increase of the first line, changing from 20 million up to 42 million. What kind of waste could it be? Water. 9 plus. No plastic. Think more out of the residual waste, not residual waste. It's excavation material. The material you get out of the soil when you build a tunnel or when you build a houses, something like that. Material excavated from the ground, and this is first in the first step. It's waste. You have to declare it as waste, and you have to treat it, or you have to landfill it. And so this is probably also about some special tunneling projects, for example, the Brenner Basis Tunnel as well, Korallen Tunnel, we had in the last years. But there is an increasing, and we do need a lot of landfills for that material. I will show you afterwards, because the recycling rate of Austria is very impacted by the excavation material as well as the demolition waste, where no recycling is taking place or less recycling is taking place. The waste, kind of waste you are thinking of, glass, plastics, biological material, is in the residual waste from households, which is not the highest number, but it's also increasing, and we are in the range of 4,500,000 tons per year. And as I said before, I just want to show you the first treatment step, or the first, how many do we recover and how many do we dispose of in 2019. And you can see here that we do landfill more of the half of the waste in the area of 46%, and this is directly correlated to the excavation material. We are not using it anymore, and therefore the recovery rate is very low in comparison to other material. We do also have a recycling rate in the area of 30%, backfilling, incineration as well. If we have a look at the different treatment steps or the different recovery and disposal without the excavation rate, this is changing a little bit, and the recycling rate is getting up very much in the area of 64%, because do you have any questions? When you build a house, normally you build a cellar or something out. So you need to put out the soil from the ground. And this soil is excavated material. In our legislation is when you put it out of the ground and you bring it to another thing, or you use it another way, it's first declared as waste, not as soil anymore. Yeah, soil, rocks, all the materials coming out of the ground. When you build a tunnel, for example, you will have also a lot of rocks and other materials. When you did, yes, yes. And but also in we declared it as waste, and this is the reason why the recycling rate for the whole amount of waste in Austria is in the range of 30%, and it's getting a little bit better, or much better, if we have to look at the material without the excavating material, the distribution of the recovery and disposal without the excavating materials. You can see that there the recycling is more than 60%. If we getting down, having a closer look coming from the residual household waste and what is happening here in Tyrol with our residual waste, also all the things you throw in your black dustbin. First, we have to announce that we are each of us producing more than 500 kilograms per inhabitant. Each of us, yeah. Everyone is producing more than 500 kilograms per inhabitant, and you can see a little bit different picture of the distribution. What happened at the first recycling step or the first treatment step? You can see that we nearly burn more than 30% of our waste in the residual dustbin. We are in the same range of the recovery rate, but we are also doing biological recycling, which means we are producing compost and producing a new product out of the materials. But yeah, we are burning a lot of things which were in our residual waste, and the problem is that we still have very valuable materials in our residual waste, which shouldn't go into the residual waste, but which were still in the residual waste, and we will have to deal with that too. So waste collection and waste treatment is always a balancing act to the convenience of the people between acceptance, financing, decentralized recycling, accessibility, mobility. So you can, all of these factors are influencing the distribution or the composition of waste and the and also the composition of the recycled and the separately collected material. Here is the composition of the residual waste of the city of Innsbruck given, and you can see a picture with a lot of colors, different materials, and I will now explain to you that we in the range of 70% of things in our residual waste which doesn't belong there. So we are throwing away recyclables, we are throwing away materials we could use in another way, but we are still doing it, and we really have to get the people awareness of that factor. The first thing, and this is together with the avoidable food waste, nearly 30% of our material in the residual waste is organics. We have a separately collected bio-waste here in Innsbruck, in Tyrol. We do have it in Austria, and in the as something natural, more or less. But even there, more than 30% were biological materials. And I'm really, each time I saw the picture, I'm shocked about the 12% of avoidable food waste. That means food which is still eatable, but is thrown away. Not the things which weren't usable anymore. We throw away nearly 10% of the of food we still could eat. And yeah, you can imagine the emissions coming around from that food waste, but it's not only the food waste where the emissions coming from. Food have to be produced, it have to be sold, it have to be transported, and so on. So it's not only the emissions coming from the treatment of the food waste, it's also a lot of emissions in the step before. And I think this is really one part, or one main part we really have to talk about people and saying, okay, have a look, please buy as less as you really need, and don't throw away such much things. And we really have to do more awareness in this area. We do have in the range of 8% of paper and cardboard in our residual waste. We do also have a separate collection for paper and cardboard in Innsbruck. We do have still light packaging waste in the area of 11%. We do have a separate collection for light packaging as well in Innsbruck. We do have glass in the area of 5%. Also, a separate collection is possible in Innsbruck. Isn't necessary to do so. The same with metals in the area of 2%. Plastics non-packaging, to the Austrian law, it's okay. They have to go into the dustbin in the residual waste. We can discuss it afterwards, but it's for the formal contract, it's okay. Also, the hygienic articles belongs in the residual waste. Textile shoes, we do have the possibility to also collect and separate them, collect them separately, and we have in the range of 5% of the residual dustbin. Electronic equipment and batteries, 2%. Here the same, we do have a separate collection. We shouldn't throw it into the residual waste. Inert material or inert waste and others, it's okay. But when you count all the amounts with the red circles, you can recognize that you are in the range of 70% of the material which is in the residual dustbin, which shouldn't belong there, because we do have a separate collection instead of that. And we really have to think about how to get this awareness also to the people and to the behavior of the people. Because people, it's an interesting thing, because when you ask the people, do you collect the following fractions separately, at least from one time to time, most of them would say, yes, sure, I do. So it's a little bit the difference, discrepancy between the thinking of the people and the behavior of the people. And for example, that is the result of an EU flash barometer, where Austria, the behavior or the answers of the Austrian people is compared to the EU median, and you can see that nearly all of the answers, they are collecting separately garden waste, kitchen waste, and so on. All the Austrians are saying they are collecting it much better than the EU. But as we saw on the picture before, we do have nearly 30% of organics in our residual waste, so it can't be. The behavior and the thinking of the people is different when they are answering in such a survey. We do get more, or we have to increase the value of products and secondary products, and we also have to think about more design for recycling. What we do have at the moment is that the secondary products are more expensive in comparison to the primary products. And in this case, nobody will buy the secondary product because it's more expensive. And we really have to discuss this, how to get the market better for a lot of our secondary products we get out of the waste management sector. So one thing is about the durable lifespan of some products, and I show you here how long should products last from a climate perspective. And you can recognize that we do have main problem, for example, with mobile phones, where we use them 2 years, 3 years, something like that. And if you have the view from the climate perspective, we should use them in the range of 23 up to more than 200 years. It's totally unrealistic, sure, but just to show you the amount of energy, the amount of for the production of the mobiles and the materials are coming from, and we are just using it. And if it's not working fast enough, or if perhaps something is broken, we throw it away. Even we could use it a little bit longer, and we really have to put much more effort on the products to take a longer lifetime. And we are discussing that in the EU, how we can do better recyclability and also to get better repair mechanism for the materials. But we really have to face this and have to look how it gets in order to not to throw it away. And even if you throw it away, there's still an amount of there's still money in the material. I will explain later on. For example, if you think of the substances which are in the mobile phones, you can have plastics, metals, different kind of metals, glass, ceramics, and some of the metals like gold, silver, platinum, and so on. So for you, it's the content or the money of the metals which were in a mobile phone is in the range of 2 euro or something like that. But if you collect them all together, you will have a much higher amount of the materials, and so it's really necessary to collect them together. For example, if you put 1 ton of mobile phones together on a place, you will have about 240 grams of gold in that 1 ton of mobile phones. And if you think about the gold ore, where it's thick, firm, and so there is only 5 grams of gold in 1 cubic or 1 ton of gold ore. So we really have to think about the valuable materials which were in the mobile phones, for example, which were in television, communication, computer, and so on. And here also again, don't throw it into the residual waste. Bring it in a separate collection. Bring it back to the collection points, or bring it back to the deliverers. It's really useful, and we can get off the materials again. Not all of them at the moment, and we do have some problems with some materials, but the research is on there, and also the industry has a high interest to get the metals out of it again, because yeah, the metals raw materials we have in Austria is very is not so much that we can use and throw it away, all the other things. And even for the production of the to extract the a small amount of gold for a mobile phone, you need to dig or you need to move a lot of kilograms of rock, and also to dissolve this gold also from the gold ore, you do a lot of or you use a lot of pollutants, mercury, cyanide, and so on. So we do have an environmental bad situation in the countries where these materials are coming from. And we also have to take it in our mind that we have to use it, the materials we have still have used, and we should use it on. And on the other side, we really have to think about what happened to the environment in such kind of digging, such kind of gold production, and so on as well. We will probably need further technologies for waste treatment and taking into account a cascading approach. This is the only slide which goes a little bit deeper in the biological chemical part, but just to show you that normally we are now collecting bio-waste separately, and we are producing compost out of it, and or we could use it in the first step in an anaerobic process. We can produce biogas and producing fertilizer afterwards. But for example, for bio-waste, it's very easy to integrate a cascading approach. And from the liquid fraction in the bio-waste, there is an amount of lactic acid in it. If you think in the summertime, the dustbin is standing in the sun, and you can smell and see something liquids in the dustbin. This is more or less in lactic acid, and we can use lactic acid, for example, for plastics, to produce plastics out of it again, and so on. So it's an easiest way to implement a treatment step before we go for a biogas plant, bring the residuals back into a biogas plant, produce biogas, produce electricity or thermal energy, or produce a digestate we could use afterwards as a fertilizer. But we can also do, if the quality of the PLA, of the lactic acid, of the polylactic acid PLA is not high enough, we could use it also for other byproducts, for example, substitution of raw materials in the food and the animal feed industry, and so on. So we can really do a lot of more out of our material, for example, for the bio-waste, but this is not happening at the moment because it's expensive in comparison to a normal treatment on a composting pile, without a lot of, or without any kind of air cleaning and so on. So it's much cheaper to do so, but I think we really have to think about where and how can we use the materials much more efficient, and for example in the bio waste, but also for the wood, waste wood, it's the same. We can also do a cascading approach, and we have to go into that direction. But we always have to keep in mind that we need an elimination of the pollutants. We will never get a cycle which is 100%, because we will have some pollutants also in the material. And so we need some kind of incineration as well as a disposal step afterwards in order to reduce the pollutants, or in order to prevent the pollutants enrichment due to recirculation. For example, if you think of microplastic in compost, we've got the legislative part where it's possible, or some administrative says, okay, you can collect your materials, your bio waste, for example, in biodegradable plastics, But we do have a problem afterwards in the composting plant, and we also find even fragments, even from the biodegradable plastics, in the digestate or in the fertilizer afterwards. So we do have a problem with plastics, and normally when people are saying, it's hard for you, probably for all of you, to distinguish between biodegradable plastic and normal plastic. So a lot of plastic which is not biodegradable is used for collecting bio-waste and is thrown also in the dustbin as well. And there we have a problem because we cut it down and it's not degradable. Even bioplastic is a little bit degradable, but normally not in the time we are doing the compost phase and the anaerobic phase. So we have the problem that we have in a range of in the compost, as we are using as a fertilizer, we do have some grams, up to 200 grams per we are bringing out as a fertilizer to our fields. Here we have to think about how to reduce these plastics fractions in the bio-waste, how to collect it in a way that they don't play a role anymore, because even if they are biodegradable, it's normally not the case. You really need a good bio-waste treatment plan in order to get the bioplastics degraded. And if you think, for example, of the small treatment plants in the small villages, it's normally not the case that it's working very well. You do have a lot of plastics also in the end product, and we are bringing it again as a fertilizer on the fields. And yeah, we are having it in our food the next time we have some agricultural things on the fields as well. And just to show you a picture, this is the metal fraction which is sorted out of a bio-waste fermentation plant, of an anaerobic process, where you really have to sort it out before. And you can recognize that there is a lot of metals, and you can recognize that there is a lot of cans also in it. This is really a special plant, but you can also recognize, when you think of bio-waste, probably you wouldn't think of such a picture, but people are throwing it away, just taking the next dustbin who is empty and put it in. And really, we do have a lot of awareness also on that kind, really collect it in the right way. And because it's necessary, you only can produce a high compost used as a fertilizer without that substances in the input material. And we really have to think how to reduce this as well. The last thing I want to show you is the promotion of the circular economy through regulatory measures. It's a question for me: which laws, which guidelines do we really need? Or are we able to do it on our own? As we saw in the last pictures, we don't have a good collection, separate collection behavior. We don't have a good behavior not throwing away metals in the bio waste and so on. So I think probably we will need more things in the direction of really put it on the regular basis. And for example, for single-use plastics, we really need to bring more reusable instead of disposable materials on it. We do have an enormous increase in disposable packaging to enjoy beverages and food on the go, but a lot of that material is littered each year. 540 tons of waste are carelessly discarded in public areas in Austria every year. The majority of the materials along the roads. You can see it when you drive down from the Autobahn. From the highway. You can normally see it in the curves and so on. I don't know why you throw it away when you are there, but you can recognize that there's an accumulation of the waste material, and we do have an increase of that beverage to go and food to go also due to Corona. Yeah, it's easier to take it. Okay, there was some time where it was necessary that we are not allowed to eat in the restaurant, so we use it and take it away. But now it's hard to change the behavior back and to cook more instead of take away. And so we do have an increase also of the packaging to go. We do have some littering hotspots, especially around the kiosk and the catering establishments. Here is an example from Frankfurt. Here we need also some action in order to reduce the single-use substances. And for example, is one try several years ago to produce a coffee cup which is reusable again. And my first question is, do you know how many coffee cups, single-use coffee cups are used in the country? Number? 200, 140, 30, 130. What do you think? 50,000, okay? It's a little bit less. Yeah, we are in the range of disposable coffee cup consumption in Innsbruck in the range of 70,000 cups per day. But even 70,000 cups per day, if you put them one on each other, you are in the range of 2,200 meters, which is in the range of the Patscherkofel each day. So even it's really unbelievable, and yeah, we really have to focus on that because it's really not necessary. And we did that project, and with some other players, with the big gastronomy dealing with coffee cups and so on. And during that project, the trend was for espresso to go. People didn't find the time to drink an espresso in the restaurant. I think even if you pay for it, you can drink it, but people are taking away espresso to go, and it's increasing. It's really unbelievable. I can understand it if someone is saying, okay, cafe latte or something like that takes longer and I'm in a hurry, but espresso to go, it's really unbelievable in my opinion. Yeah, just want to show you that we are trying to arrange something there, and we will get. Yeah, we did that project, and you can even now buy the cups in the participants of the project. But one result is also that now you will get a reduce of money if you bring your own cup, independent if it's this cup or another cup. If you are going to the M-Preis, for example, you will pay for your coffee to go 30 cents less than when you buy a single-use cup. So I think this is one of the success of the project as well, and hopefully we'll get more in the future. The other thing is to go food, beverage to go. The other thing is the food to go, convenience food. We did a survey of the gastronomy and food retail trade in order to have a look how many waste they do have in the different areas. And for example, one business A is producing in the range of 160 tons of black polypropylene cups and 4-layer films per year, which is corresponding one business, which is corresponding to approximately 1% of the total plastic amount of plastic waste in Tyrol. So there is an influence even coming from the food to go as well, but also looking for pizza delivery services. We have in the range of one business in the range of 30,000 pizza boxes per year, which is in the range of nearly 4 tons of waste each year. And another restaurant delivery service in comparison to normal restaurants with the option to take away food, we are in the area of 0.6 tons per year. If you extrapolate that to Innsbruck with 25 pizza delivery services, you will have 40 in the range of 40 tons paper and cardboard per year. And there are some new products on the market in order to reduce these amount, for example, to the half. And I don't know if you have seen, for example, the one, it's from Pizza Bowl, which is it's made of plastic, so we can discuss this. But for to go, it's mostly the preferred option, and you can use this instead of the normal cardboard packaging, and you can really try to reduce. You can buy it on your own. You can bring it to the pizza delivery. Not all of them expected, but there are some first steps going into the direction also to do more reusable packaging material in the area of food to go as well. So let me come to the conclusions. We've seen that we have a decreasing share of greenhouse gas emissions from the waste sector, and this is directly correlated with the closing of the landfill in regard that it's not allowed to bring untreated waste to the landfill, and due to that we could reduce the methane emissions in the last years. But we really do much more awareness with the problem waste, with the behavior of each of us, to take part in the separate collection and to take part, not only to take part, to take good part and do it in the right way and to put it in the right dustbin and not throw it away, and not to take the single collected plastic in the bio waste to put it really in the right dustbin. We do have a very good system, and we really have to get the worthwhile materials which were in the waste in order, and in the most of the cases we only can do a good recycling if we have a good material product, or if we could have the materials sorted in the right way and can use it in afterwards for recycling. We do need more cascading approach, and what is really much important in order to prevent, we do need more reusable instead of disposable materials. And I think here we have to change our way of thinking, our behavior, to take a reusable cup with us if you're planning to drink coffee that day, instead of buying a single-use cup. And with that, I want to thank you for your attention, and